Alright, so this is going to be our last notes on rocks, and this is going to be about metamorphic rocks, and I'm going to add a few things to interact for you with on the site, on the Google Classroom, so be paying attention to that, and we'll be finishing up with rocks and minerals and such. But this is metamorphic rocks. And if you know metamorphosis, like a butterfly where it changes from this little larva into a butterfly, something very different, that's kind of what happens here. A metamorphic rock is a changed rock. Okay, and what happens, what really gets changed in these are the minerals. So we know rocks are made up of different types of minerals. Sometimes they're made up of only one or very few, and depending on how many types of minerals are in the rock, then that forms different types of metamorphic rock, and we're going to talk about that as we go through these notes. So the main thing you need for metamorphism to occur, or for metamorphic rocks to be made, is heat and pressure. Okay, and the heat cannot melt. Like if we did melt, right? We'd make a sign out of it, and we'd say no melting. Can't melt. Or because if it melted, it would then become an igneous rock. But here we have melting, but not enough heat, but not enough to melt it. And also we need pressure. So we're going to talk about how that gets formed. And if you remember from plate tectonics, and a lot of you should have this kind of really good background with this from middle school, and if you've had me, plate tectonics is, talking about this idea that the Earth is made up of, quite a few plates that are moving around on the core, or the mantle, and they bump into each other, and one goes underneath another, or they push up each other, and that's where we get that pressure. So the pressure is really coming from plate interaction for the most part. And so subduction zones, where one plate goes underneath another, or volcanic areas where magma's coming up out and really stressing the area. You can have metamorphic rocks around, so it shouldn't surprise you that we have quite a few of these where we are, because we have volcanic. We have an old volcano that's kind of dormant, but we can find a lot of volcanic rocks around here, and even the Chugach Mountains are metamorphic mountains, if you've ever checked them out, looked at them closely. And these tend to metamorphic rocks. They form at plate boundaries and other places where volcanic activity, like here, volcanic areas, where that is occurring. But they're formed by heat and by pressure. Okay, if you want to identify one, though, you're looking for two things: texture, and if you remember from igneous rocks, we kind of talked about texture as well, and composition, and this is talking about the minerals that make it up. Okay, but here texture is something different. It's something called foliated or non-foliated, and really what that's talking about is something aligned in it, or is it not aligned? Okay, and the aligned part again are the minerals. So they get heated, not melted, they get heated up, and they get rearranged, and many times when they do that, they form bands, and we're going to look at that in a minute. And there can be any degree, and they often call this a grade of metamorphism. So, a grade. So this is, slaty is something you really can't see the minerals have rearranged, but you can kind of pull the rock apart and you can see it has layers. Phylitic is still kind of almost getting there, but you still can't really see it very well. And then schistose is really occurring, and then gneissic is it's just clear banding. We'll take a look at this right now. So if I go to it, okay, so here's an example of this. Okay, so shale, this is increasing temperature and pressure, okay, and that's what causes this to occur. So the lower temperature and the less pressure, we still get metamorphic rocks forming, but we don't see the clear lining up of minerals. But it's still there if we really looked at them with a microscope or try to pull it apart. And then slate kind of forms, we can see the layers, still can't see the banding yet. Phyllite, you can start to really see it a little bit, start to see it more, and more, this is more temperature, higher temperature, more pressure. And then schist, you kind of start to see it, like some layers, and then gneiss, really clear bands. See, it almost looks like a sedimentary rock because of that. And then this is really clear one here. Look at all these banding, and the this is, you know, some bending here, and this is where this actually partially melts to form this. Okay, and then the stress is, you know, these minerals melt, not melt, but they get heated, and that causes them to move around, and then the stress causes them to be formed into bands. So here we have this kind of rock here. Before metamorphism it looks like this, but eventually it changes into this, so you can start to see these clear bands that happen as well. And then here we kind of see these, you know, minerals, and then they kind of get aligned, they get more aligned and pushed together, they kind of join together, form more familiar or more obvious banding, and then, you know, gneiss, really, they're just many layers. It's just really obvious is what it is. And here's another example of a gneiss, just clear layers that you can really see. Okay, but then we also have something called non-foliated, where there really isn't any banding. No bands here, you can't really see them, and that's because there's only one type of mineral. So, you know, here we have more than one type, so they can align and form into different regions. Here it doesn't really matter because there's really only one type, and that's what non-foliated means. Okay, so if you go back to our notes, so aligned or not. And non-foliated, if you remember, we said was one mineral, so let's add that. One mineral. That's why you can't really see banding, because what's happening with foliated and forming bands is where the minerals kind of line up, and if there's only one type, you're not really going to see a difference. Okay, so let's keep going here. I'm going to erase this. Hopefully these notes aren't going to get messed up here. Okay, so that's kind of the degrees or the grades. Slaty, can't see very much. Phylitic, see maybe almost, and then a schist, kind of really start to see it, and then gneiss, really clear. So we could even move this one over and say it's actually the last grade of foliation. Really clear. Okay, and then we can look at metamorphism and understand it as a process that occurs. So within metamorphism, we have different types of rocks that are formed according to the degree of metamorphism that occurs. But we can also have types, and that's talking about how much of the rock has been affected and how widespread is this process. Let me go back. So we'll go down, and you have two types: regional. And really, it says here, most are this. And this is a large area. We're talking about mountains. So you look at the Chugach Mountains, they are regional. They're all metamorphic. So a lot of heat and a lot of pressure and, plate boundary. PB, plate boundary. So we live in a place where we see this metamorphism. But then you have contact metamorphosis. This is a small area, and we're going to look at a little animation here in a minute and look at that just to give you a better idea. But this is where you have some of this, perhaps this regional stuff occurring, but then small areas are affected. Not enough to say it's a regional, but just a small area where there's enough heat and enough pressure where just a smaller area of rock is affected. So if we go back here, and we're going to clear that. Okay, if we go down to this diagram, and we can see this is metamorphism. Okay, and we can see kind of we got this this is one plate going this direction. Maybe I can draw with this. So we got a plate going this direction. We got a plate going this direction. This is continental crust. This is oceanic crust. Much more dense. So when it hits, it's going to go down underneath. This is all just a big slab of crust right here, and so is this. And then this one bends underneath, and you can just imagine the pressure that occurs right here. Okay, but you also have volcanism that occurs because as this happens, water gets dragged underneath, and that causes the magma, or allows the magma sometimes or some of this rock down here to get melted when it normally wouldn't, because it just changes the conditions, and then you can have these volcanoes form, and when that's happening, you can have metamorphism occurring as well. Let me shut this off. Okay, go back. Wait. Okay, so let's look at this regional, and there's contact. So you can kind of see the contact is right here. It's circling. So we just had this little volcano here, and you had this little bit of magma working its way up. And as it does that, it forms just a small area of metamorphic rock. We compare that to regional. Okay, much larger area. Just this whole plume right here. As it forms, it just spreads out and forms these large metamorphic rocks, and eventually, if they were pushed up enough, they could form a mountain. Okay, and if we look back here, we can take a few look at, and here's some, looks like phyllite. Let's look at a few of these. Here is marble. This is limestone that becomes marble. And then here is gneiss. This kind of shows you that and how the minerals line up a certain way. And I'm probably going to assign this to you and have you check it out. This interactive resource here. But that's kind of the two types. So if we go back, so we can look at a fault here. So you got pressure here, right? We got some. This is forming down here. We got some heat from over here. That's enough to form some metamorphic rocks. And let's look at hydrothermal. That's this spreading center. It's kind of a weak spot in the crust and a hot spot, and lava comes up through here and metamorphoses this rock right here. And then if we look at one more time, I think that's probably it. Yeah, here's the contact, just a small area. Here is the regional, huge, much larger area. And that's it. So that's kind of an overview of metamorphic rocks. Hopefully that helps you understand it, the main terms that go with it. Make sure you complete the reading, and this will finish up for rocks and do some identification, finish that interactive, and you'll be done.